idea to grab the haunted house PNG. Look at that little haunted house there. Spooky. And you also want to get this Franken-zip and unzip that. One of the first things I want to show you that's not related to the lab at all, but is a handy trick, is if you're using RStudio, there's this little button here. You can see it. It's like a window, and there's an arrow pointing out of it. And when you put your mouse over it, it says show a new window. I like this button a lot because what it does is it basically takes your script and breaks it out. So now you'll see that my script is now separate from my RStudio. And this could be useful if you use multiple monitors, if you want to spread your code out a bit. It's useful for me in this case where, because I'm using a projector, it squashes down my screen. This allows me to just easily have a text file and to move it back and forth so that we can see what's behind it. So it's just a little bit easier to deal with. And again, if you click that button, return to main window, it'll just plop it back into your RStudio. So it's not going to look like a very realistic bat, but I think it's very useful to know how to make basic shapes in R, and to be able to combine shapes together to make things that look like other things. In this case, making circles and squares and triangles look like a bat. And so the first thing that I like to start off with, especially with a bat, is I imagine it has like a round body. And so we can just start very easily with the plot function x equals 0, y equals 0. So this is going to make a point at 0, 0. Well, let's just see what that looks like. So we can see how this will change over time. All right, so we start with a circle. Let's make this circle bigger, right? We want our bat to look a little bigger. To make it bigger, it's a CEX tag argument, what have you. And let's just make it an 8. There we go. So that's a bigger circle. The next thing you want to do is maybe you want to fill this circle. You want it to be like a solid type of circle. The way you do that, well, one way, the way that I suggest is you change the PCH. The PCH stands for point character. Putting different numbers in here allows you to change things from like X's to pluses to diamonds to open circles and filled circles. And the filled circle is 19. So if you do that, now you get your filled circle. It's right there. And maybe I don't feel like having a really black bat. I want to give it a different color. So we could do call, and then I'm just going to go with gray 40. So the interesting thing with the gray color is there are colors that are gray 0 all the way to gray 100 that go by 10. So you could easily have put in gray 90, gray 50, and those gives you different different shades of gray. Right? Yeah. So when you plot that, you'll see that it changed. We can go back on the plot a little bit so you can see from black to a little bit gray. What we can do, I think the first thing I want to do is actually I want to scale this image because I want other things to be in the scene and I want the bat to be a little bit on top. So I'm just going to set my X lim and my Y lim. I'm just arbitrarily going to set X lim to minus 1.5 to 1.5. And again, what this does is you'll notice right now our plot kind of goes from -1 to 1. Once you put that argument in and run it, now we'll see that it goes to -1.5 to 1.5. And we can do the same thing for the Y. Let's set our Y lim to -7 to maybe 1.5. So when we run that, we see, okay, now we have a bat that looks like it's in the air, right? We haven't actually changed the bat's position. The bat is still being plotted at 0, 0. But we've given the bat sort of this space to be able to fly in, work in, what have you. All right, so the next thing I want to work on is adding wings. And the way that you can draw shapes in R is using the polygon function. So let's look at the manual really quickly for polygon. Nope, not there. Oop. Polygon. So if we look at the R help file, we'll see the two main arguments are X and Y, vectors containing the vertices of the polygon. So for example, if we wanted a triangle, right, those are 3 points, 3 vertices, we'd need an X and a Y vector that gives the X and the Y position of those 3 different points. Once you input those x and y values, the polygon function will fill that entire space with color. In this case, you could control how much color there is by density. Density refers to how many lines it'll shade through your polygon. If you just ignore density at all, it'll fill the entire thing. And the other kind of interesting thing that we want to look at is color. That's very standard. You can change the color of those lines. But so let's start off by adding some wings. Let's make a point here. So it's going to be, the x value is going to be a little offset in the negative direction. The y value is going to be a little offset in the positive direction. So we want to target a point here. Then we want to target a point there. And then finally we want to target a point here, right? So that's our 3 points. If we can get those 3 points, then we can make a wing. And so I played around a little bit. And I found that for x, to put in 3 points, first of all, you need to use the C or the concatenate function. And I found that at minus 0.1, minus 0.3, and minus 0.1 are good for the x values. And again, that's referring to negative 0.1 over here, negative 0.3 out there, negative 0.1 over there. Right. And so we can do the same thing for the y. I think the good values are 0.50 and 0.5 for the y. And again, that refers to the y value being up here at 0.5, the y value being at 0, and then this has to be negative 0.5. Negative 0.5. So let's just run that and see where the wing falls on our shape. That's not bad. We can maybe mess with that a little bit. Depending on your display, it can look different. And so I'm just going to mess with it a little bit. Let's say that I want my x to be more than that, 2.5 and 2.5. So that was too much. 1.5 and 1.5. Again, these numbers are going to be different because they're all dependent upon your screen. So you just want to mess with it until you get shapes that you're happy with. And every time you run this, it'll just add on top of the plot. So you see it'll get really messy really quickly. To reset this, all you have to do is run the plot line again. So you get your circle back, and then you can see where these values will land. So I'm still not happy with this. Maybe we'll go that. And then maybe I want my y values to be a little higher and lower. 5, 5, 5, 5. So you can mess with this until you get a wing that you're happy with. Maybe I want this to go a little more. Whoa, that's looking like a better wing to me. So just mess with those numbers until you get something that looks like that-ish, or something that you're happy with at least. You can mess with it forever, but I think that's good enough. And so the next step now is we want to color it in, right? Because right now there's nothing in there. So what we can do is we can set color is equal to, I'm going to set it as the same color as our circle, gray 40. Color gray 40. And I'm also going to mess with the density. I'm going to make the density 50. Let's see what that looks like. So when I run that, there we go. We get a nice little gray wing. And if you look closely, I can't zoom in very much, but there are hash marks in there. This actually isn't filled all the way. There are slanted lines. It's just that the density of 50 is so tightly packed together that it kind of looks like it's a solid color, but it's a little bit lighter than what we expect. Yes. So that's something you want to avoid. Basically, once you set up your dimensions, those numbers will only work for those dimensions, right? All right. So if you're happy with your left wing, it's very easy to put a right wing on there. You can just copy and paste this. And the y values will be exactly the same. You want the wings to be symmetric. The only things that will change will be the x values. And in my case, all of these are negative with respect to 0. So to do a right wing, we just have to change all these values to positive. It should be pretty simple. Positive, positive, positive. Run that, and we get a right wing. that's looking closer and closer to a bat. All right, so let's add some ears, just because this doesn't quite look like a bat. Again, we're going to be using the polygon function. We're going to have an x, and I'm thinking I'm going to start with an x here. The next point is going to be up there, and then it's going to go down. So I'm going to make a triangle that looks like 1 point, 2 point, 3 point. So our first one will not be quite at 0. It'll be a little bit less than 0. So maybe 0.5, 0. Let's just do 5, negative, and negative 0.6. Again, I don't know what this is going to look like. We're just going to have to mess with it to get something that looks right. And for y, I'll go to 0.1, 0.3, 0.1 maybe. And we'll just see what that looks like. Oh, so that's way off. What I meant to do was 0.5, 0.5, 0.6. And I want the y's to be higher, because that's not high enough. So maybe we'll do 5, 6, 5. And again, you just mess with these values until you get something that works. Unfortunately, because it is very dependent upon your frame, it's not going to be the same every time. Okay, so I came up with something that looks like this. That kind of looks like an ear. Not quite there, but it kind of looks like an ear. And again, you do the same thing. Once you have an ear that you're happy with on the one side, you can put it on the other side by making all these values positive. The y value shouldn't change, it should be the x values. Do that. And I'll do the same thing. Color equals gray, 40. Density equals 50. Color equals gray 40. Density equals 50. All right. It's like a cute looking bat, kind of. All right, so that's sort of like the basics of drawing shapes in. There's one more thing that we need to do in order to make this easy. So if we wanted to move this bat right now, we basically, as it for an animation, we'd want to plot it in a different place. As it stands, that's kind of difficult to control right now because we just have all these random numbers. But one thing to realize is that all of these numbers are in relationship to 0, 0, right? So if we can somehow programmatically change our reference point from 0, 0 to wherever we want our bat to be, say 1, 1, then that's an easy way that we can control this bat. So what you can do up top here is say your bat x is equal to 0, bat y is equal to 0. And now this is sort of the tricky part. You have to go in here, and every part that is referring to this reference point, you just replace with bat x and bat y. So instead of x equals 0 for the x location of the body of the bat, we can just replace this with bat x. And the y, we can replace this with bat y. And just to check ourselves, you can run bat x, bat y, run the plot. You'll see that that's at 0. You can come back up here and change it to 1, 1, and run bat x, bat y, run the plot, and now that circle should be somewhere else at 1, 1. So we know that this is working so far, 0, 0. Now we have to do that for the wings and the ears. And so we did a really good thing because we started our bat at 0, 0. It's very easy to plug in the 0 because all of these numbers they're relative to that 0 figure. So every time there's an x here that says negative 0.15, actually you should be thinking that this is 0 minus 0.15, and the 0 is the same as bat x, right? I don't know if that makes any sense. Maybe I'll say it one more time. That whenever you see a negative or positive number, it's in relationship to this 0, 0 point. So you could think of this as a 0. And if you can think of this as a 0 and you know that this is an x value, you can change that to bat x. This one also becomes bat x. This one is bat x. Over here, because we have some positive numbers, we have to do bat y plus. You can do bat y plus. But because it's a 0, we don't really need to do that. And then there's a minus here, so we do bat y minus. So I'm going to do that for the rest of them. Bat x minus, bat x minus, bat x minus, do bat y. Okay. So once you've done that, you can just run all of it and see how that falls out. We might have messed up somewhere. Oh, there should be a plus here. That's a plus.
Should we do it for the plots, x lim and y lim as well?
No, so the x lim and y lim should remain static, because that won't change if the bat moves. All right, try it again. There we go. So now you can see that if we change the x position to like 0.5, the bat shows up in a different position. So that might have been a pain in the butt to do, but because we did this, now we can control the position of our bat with just these two numbers. And actually, you should be thinking about your code. You should look for opportunities that you can do this in, because what we've done is we've written a very rudimentary function, right? You can think about it as all of this code happens in relationship to these two input parameters. And so we can actually turn this into a function. I'll do that really quick. We'll say plot bat is equal to a function where we provide some bat x, we provide some bat y, and then having these curly brackets says that it will basically all the code in between the curly brackets that refers to bat x and refers to bat y will be replaced by these numbers that we put into the function. All right, and so all I did again was I made some name plot bat, and by doing this I made it into a function, and that function is expecting two parameters, bat x and bat y. And then I added these curly brackets to signify that this bat x and bat y only refers to the things that are in here. And whenever it finds a bat x and whenever it finds a bat y, it'll take the numbers that we put in here and replace them. So what does that mean for us? Ooh, that's not what I wanted. That means now, well, the first thing we have to do is we have to run the code. So I'm going to highlight it and I'm going to do Command Enter. And you'll see that nothing actually happened. We don't get any errors. But now we have this function called plot bat, right? And you can see now that just that tooltip tells us that plot bat takes in a bat x and a bat y. So if we put in a 0, 0, again, we can do these tabs just to be very specific about these numbers. We do that. We have a bat at 0, 0. I just push the up arrow to get that line back to recover it. And now let's do maybe, we want to move the bat a little bit to the right, maybe to 0.1. So now when we run this, if we look at that bat, it moves a little bit. And so you can see that now that we have this function, it becomes very easy to animate this bat. We just have to run this function however many times we want, slightly moving it each time. Right, so if we scroll back through these pictures, you can see that bat's kind of just strafing left and right. Next thing I want to do is add a haunted house, just because it's a little incomplete at this moment. And so we're going to do something a little new. On my website, I gave you this picture of a haunted house. We're going to learn actually how to import an image and how to place it onto a plot. This is very useful for plots that are dealing with multiple species, where maybe you have like bar graphs and you want to put an example of like a taxonomic example of what it actually looks like. Maybe you want to put in a little cartoon in your plot. It's very easy to do that. And so the first thing you'll need to do is install a package, because R doesn't do this on its own. And so the function is install packages, and I believe because this is a PNG, we'll want to install the PNG package. So the code is just install packages and PNG. This has the possibility of not working. I know some versions of R, it becomes really tricky to install packages this way, but I'm just crossing my fingers and hoping for the best. It's giving me an error because I already have it installed and loaded, but you should see it working, and you'll see, I don't want to move my plot window, but you can kind of see what it did. There's an indication that it downloaded, and there are no errors, so then that means it's downloaded for me. If you want to check whether or not it actually downloaded correctly, you can click this Packages tab and find it. So it's a PNG, Elemento, PNG. So there it shows up. Read and write PNG images. You can do that by clicking this. The other way that I like to do it is using library. You can just do PNG. It loads it. And you can even nest these commands within your functions that require it, so that it'll just pop it out. Is that what you're?
Yeah.
Okay. All right, so if you have this, you'll notice that you now have a read PNG function, and it just takes in the file. Let's see if I can grab it. So I am looking for hauntedhouse.png, and I'm going to store it as haunted house. Okay. So when I run this, nothing happened again, but no errors, which is good. But now I've created something in my list that is a haunted house. If you actually type it and look at it, you'll see that you get this really like strange looking three-dimensional array. And it's maybe worth mentioning a little bit what these are. Basically, when you think of images, especially PNGs, they can be divided into RGB, red, blue, and green color scales. And so why this is a three-dimensional matrix is because there's a matrix for the red, there's a matrix for the blue, a matrix for the green. And what these matrices are for every pixel in that image, there's there's a cell in this matrix, right? So you basically decompose an image into a matrix. And what these numbers represent are the intensity values of that color scale. So for every pixel, if you're looking at the red matrix, this is basically saying that the brightness or the intensity of that red at cell 798 by 1 is this value. So that's how images can be decoded into these matrices. So the cool thing is once you have that, oh, I moved my thing, didn't I? That still looks like a bat, doesn't it? You can plop it down anywhere you want using the raster image function. So the raster image, to quickly look at the arguments, it'll take an image, and again, this image is this array that you just read in. So I'll do haunted house there, and then now it's going to ask for these four things: x left, y bottom, x right, y top. These are the points, the boundaries of the image that you're trying to import. So I'm just going to say my x left is maybe minus 1.5. My x right will be 1.5. So those are the boundaries of my image that would be plotted there at negative 1.5 and 1.5. Y bottom, I'll put that at negative 7, and y top at minus 2 maybe, so that it shows up underneath that bat. And so now, let's just see if this works. So I ran it, and there, I put a little haunted house underneath, just like that. So let me put this code back up so everyone can see it. Where is it? There it is. While this is up here, I'm actually going to functionize this as well. I'm going to make a function down here and call it add image as a function. And it's going to take in an image. And what it will do is that same thing, that same code, but instead of telling it specifically haunted house, I'm just going to say image. And again, this image is going to refer to this image that I set up here. That way we have something that is that we can use universally. So now if we want to plot our bat, let's say at 0, but we want to make the bat dip down a little bit, so minus 0.1 or so. We run this, it clears off everything, right? But now we can just add image, and here we can just type in haunted house, and our haunted house gets added to that image. And so this isn't spooky enough yet, just because we can see all of these things. It doesn't look very real. So I'm going to do one more thing, which is before we do the plot, I'm going to change a parameter using the par function. And this time we're going to change the background color using BG, and we're going to make that black. So now when we set that par, no errors, nothing happens. But now when we make our new plot, it's on a completely black background. That looks like a spooky scene. So I briefly want to talk about how we can animate this and make this, I mean, eventually by the end of today, I want this bat to do figure eights. And it's actually very hard to write an XY, Cartesian coordinate equation for like such a simple harmonic motion like that. And the way that you can represent really complex harmonic motion is by using a parametric equation. And so I included this called the butterfly equation. I'm actually going to clear all of this off by using dev.off, device off, and this clears everything, including the fact that we set the margin as black. But you can run this code, and once you see it, then we can talk about it. So when you run the butterfly equation, you get this like really pretty butterfly. It's kind of neat. But the way that we were able to generate this very easily is we control the x via some equation, and we control the y via some equation, and we sync them together via time. So when you hear about parametric equations, usually what you'll see is there's some factor of time, and then you'll get a y1, a y2, a y3, a y4. They very rarely go into x and y because that idea kind of limits what this can do. But you could basically explain different dimensions of data that are synced via time or via frame or via row number in this case to generate this. So by plotting x and y, we get the butterfly. If we actually plot y equals y and x is equal to t, just to see what it looks like against t, again, this may look like a very difficult graph to explain, but actually you can use a series of sines, cosines, exponentials to explain this very, very easily, much more easily than you would a normal system. And so the reason I bring that up is because if we want to get our bat moving left and right, we can borrow some of this and use somewhat of a harmonic equation. I'll show you very simply how to do it for a couple frames. So we definitely want to have some x value and some y value. And for a very simple animation, let's just make the bat move left and right steadily. So what we can do is use the C function to give x coordinates for a certain duration. So let's say that the bat starts at 0, it goes to minus maybe 0.5, then it goes to minus 1, it comes back to minus 0.5, then it goes back to 1. I guess it goes to 0. And then it goes to 0.5, and then to 1. All right, so if you just look at these x values, it goes to 0, negative 0.5, negative 1, negative 0.5, 0, 0.5, and then 1, right? The y value doesn't change that entire time, so we could, put as many y values as there are x values, but I like to use the repeat function. So we'll repeat 0. And then what we need to put here is how many times we want to repeat 0, and that's the length of x, right? So we could say 1, 2, 3, 4, 5, 6, 7. We could just say 7, but to be even more clever about this, we can just say the length of x. So I'll do that, I'll do that. We now have this x and we now have this y, which are the different values of bat x and bat y that we want to set for our plot. So what we can do is use a for loop to run through this very quickly. I in 1 to length of x. If you've never seen a for loop before, very briefly, what we're saying is we're going to create a temporary variable I, and we're going to run this thing we're going to run the code in between these brackets, each time replacing I with 1 all the way up until the length of x, which is 7. So it'll run it once, it'll run it twice, it'll run it 3 times, all the way until running it 7 times. And so what we can do is I'm going to copy and paste our plot from up here. Now that we have this nice function, it's simple to put this in here. And now instead of bat x equaling particular numbers, we can set these x's and y's to refer back to these x's and y's. So bat x is going to equal to x square bracket I. And what we're saying in this case is the first time we run this, we want bat x to be the first value of x. When we run it the second time, we want this to be the second value of x, the third value of x, the fourth value of x, so on and so on. And we're going to do the same thing for bat y. Y is going to be square bracket I. And just to make the animation work in RStudio, I'm going to introduce a lag so that RStudio has some time to plot this and catch up. So in order to do that, there's a function called sys.sleep, I believe. And we need to put in a value in here in seconds, so I'm just going to say half a second. So what it'll do in this loop is that it'll run it once, it'll wait half a second, then it'll run again, it'll wait half a second, then it'll run again, it'll wait another half a second. It just gives the plot a little bit time to catch up. So I'm going to load it. Here's my x, here's my y, and I'm going to run my for loop, and then we can watch this plot. So there's the bat. And it's moving, 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 moving. And it's done. So based on that, that's fine. We could do that. We could figure out what numbers we want to put in here to make a figure 8. But as you'll see, one of the exercises is to make the bat sway left and right for 45 frames. It's very tedious to do that on your own, to input 45 different numbers. But based on everything that we have here, I mean, we've simplified these functions a bit. The only thing you need to figure out is how to make this x and this y. Based on sort of what we kind of see here, like for example, we can make a t by using a sequence function. And this is it just goes from 0 to 8 pi, and the length out is how many data points we want there. So you can sort of figure out, or try to work for it a little bit, and try to figure out how to automatically make this bat sway left and right for 45 frames. So that's a good strategy. But going from -1 to 1, so making the sequence from -1 to 1 will only make it go sweep one way, right? But what you can do is you can make 2 sequences, sweep left, sweep right, and then use the C function, the concatenate function, to stitch them together. You just have to make one 24 frames, the other 23 frames or whatnot to make that happen. So right, so that's a tricky thing. Like you'd have to make a sequence saying like sweep left and sweep right, and say like x is equal to c sweep left comma sweep right. You put them and like just join them together.
And then you put 45 in here for loop.
Yes, then you could do for. In that case, you could, since you know 45 is what you want, you could do for I in 1 colon 45, so 1 to 45. Or to be a little bit more general, you could say from 1 to length of your x. Because your x at that point should be your 23 plus your 24 frames together. The other thing that you might want to consider is actually, so if you think about the motion, you start here, and you go there, and you go there, and you go there, and you go there. So another way that you can represent this kind of motion is using a sine function, right? So like sine of 0 is 0, cosine of 0 is 1. Yeah, so if you could set some t to go from, like in this case, from 0 to 8 pi, and then your function is just, your x is equal to the sine of t, then you can just have a whole bunch of x's going left and right. And the reason why it's helpful to do it that way is they don't do the exact same thing. So for example, if you go with the sequence way, there's no slowing down. It's just full. It just bounces back. If you use the sine function, the way that the unit circle works is that the closer you get to the edge, the more it slows down, and then it does, like kind of like has that lag period. But the reason why that's useful, in this case we're doing a figure 8, is the y could be the same thing, just at a faster frequency, right? So if you have your x doing this, but you have your y like doing that, you could get some really crazy bat flying movements. So that's something to trying to get sines and cosines to work. And this last part, make a bat do a figure 8 for 45 frames and then go straight up for 21 frames. That would need a combination of the things that you had put together. You need to do a figure 8, I think you'd have to like do some sort of sine cosine thing. And then separate from that, you'd need like another set of directions for the bat just to stay in the same x and then to rise up in y. Then you concatenate those two together. So then you have one thing that does this, and then it goes up. I ended up putting up this little bonus thing that I wanted to share with you guys because I think it was kind of cool. You can try it. I do hope that we get to it sometime. But where's my scratch R script? So I ended up doing making the bat do a figure 8, and instead of having a haunted house there, I ended up also putting frames from the Frankenstein movie to go along with it. So it's not perfect, but you can kind of no, it needs to be spooky. I want that. So you can kind of see that it doesn't even have to be like a still picture. It could be a series of images that interact with your plot. So as this bat is like going around, I mean, so the monster's actually experiencing light for the first time. But I mean, like, just neat little things that you can do. It opens up, some of the capabilities of R. And also this is very slow, but what can happen is you can also punch out these frames one by one, process them into an AVI, and have that go at real speed instead of this. But for now, this is kind of a cool little thing. It just goes away and he ends up looking sad. So close. Anyway, we'll probably return to doing this because I think it's important to understand how to process videos in R. But in the meantime, you have all the files and pretty much most of the skills that you need to attempt that if you want to.